what are alkanes? Yeah, alkanes are a group of organic compounds, specifically hydrocarbons with the general formula CnH2n plus 2. What does that mean? Before you go into the details of it, I want to point out one interesting thing. The subscript N below the C refers to the number of carbon atoms present. So the general formula of carbon is CnH2n plus 2. What do we mean by the general formula? It's basically a mathematical expression or an expression that tells us the number of hydrogen atoms needed to bond with a given number of carbon. Got it? Yeah. So if n is equal to 1, that means C is 1, C subscript 1. Wherever it is 1, we do not show 1, we do not write a 1. So C is 1 and H will be what? Mind you, H is 2n plus 2. So n is 1, so 2 times 1 is 2, plus 2 is 4, so H 4. So what that means is carbon is bonded with 4 hydrogens. So you have 1 carbon in the middle bonded to 4 hydrogens. You see that this is a methane. What if n is 2 instead of 1? If n is 2, it means C is 2. You see that? And H will be what? H is 2n plus 2. So 2 times 2 is 4. 4 plus 2 is 6. So C2H6. So this will be the formula. Good. And their displayed formula will be this, ethane. So you can see that we have 2 carbon atoms, carbon bonded to carbon, and 6 hydrogens spread around it. You can count the number of carbon and number of hydrogen atoms, and you will see the point I'm trying to make here. What if n is 3? If n is 3, C is 3, and H will be 2 times 3 is 6, plus 2 is 8. So C3H8. Interesting. But I have an assignment for you. If n is 3, we have C3H8. What do you think will be the displayed formula? How would we draw the displayed formula? Yeah, just practice it. Let's say try it out. But to help you, just draw 3 carbon atoms, C, 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 and spread hydrogen around them. That will give you the displayed formula of C3H8. So basically, that's the general formula of alkanes. Yeah, interesting. But let's look at something amazing. That is homologous series in alkanes. So we've seen the first 3 of alkanes, molecules. Yeah, we've seen them, but let's get homologous series. So these are the first 3 alkanes. Instead of first, no, this is first 4. Yeah. So these are the first 4 alkanes: CH4, C2H6, C3H8, and C4H10. These are the first 4 alkanes. Now look at this. Let's consider the first 2. From the top, the first 2. Good. Now from the first 2, let's look at the difference between the first 2. What do I mean by the difference? Let's pick the lower one, which is C2H6, and then subtract CH4 from it. Yeah. So we'll pick adjacent alkanes, pick the lower one and subtract the upper one from it. So we have C2H6 minus CH4. So we are going to subtract the subscript. So we have C2 and H6 and CH4. So considering the C, 2 minus 1 is 1, so we'll not show it. What about the H? We have 6 minus 4 is 2. Did you see that? So if we subtract, we are going to get CH2. I'm wondering how I'm struggling with this easy word there. Now we have the next one, C2H6 and C3H8. Let's subtract and see. So let's pick the lower one, C3H8 minus C2H6. So the C, 3 minus 2 is 1, so we'll not show it. The 8 minus 6 is 2. Do you see that? So the point I want to stress on is that if you pick alkanes and subtract subsequent ones from each other, like adjacent ones, like the ones we just did, one interesting thing you realize is that they all differ from each other by what we know as a methylene group, which is CH2. That's the difference. They differ from each other with CH2. So you can try it out. C3H8 and C4H10. Do the C4H10 minus C3H8. You would see that the difference is CH2. This CH2 is known as a methylene group, which means is that when we are arranging organic compounds, they differ from each other with that fixed number of carbon and hydrogen. And that is what we refer to as homologous series. So a homologous series is a group of organic compounds that share the same functional group and exhibit similar chemical properties. So CH4, C2H6, C3H8, C4H10, they show the same chemical properties. But here's the point. With successive members differing by a methylene group. So homologous series is basically what you see on the screen. Successive members differ by a methylene group. So that is what a homologous series is. So our understanding of homologous series for alkanes applies for the remaining organic compounds. So if you find this lesson helpful and beneficial, give it a thumbs up, subscribe to the channel, leave a like or leave a comment, and share this video with other students who benefit from lessons like this. So what will we be discussing in our next lesson, the sixth lesson? We'll be looking at how to name straight chain alkanes. So see you in that lesson.